All right, good morning, everybody. So what I thought we'd do today is I'm going to put up a problem, and then I'm going to have you answer just yes or no. Could you do it? Can you not do it? That's going to give me feedback to see which types of problems we need more practice with for Monday. And then after you hit yes or no, then the video will continue on, and I'll go through the solution. All right, so let's go ahead and get started, and the test will be similar to this. This is kind of like a D-Day number 3 type thing. All right, here we go. Practice quiz, practice test. All right. So your first question, I want you to solve. And then the domain is limited from 0 to 2 pi. All right, let's go ahead and take a look at this. So as I look at this is the most complicated part of this whole equation. So what I'm going to do is I'm going to change this using my identity page. Everybody should have their identity page in front of them while they take this. So now, my only option for this one is 2 sine x cosine x. That's from the double angle identity here. All right, now I'm at the point, I've got it all in terms of sine and cosine. Now I got to look for GCF or factor. I can factor out a cosine. Right, if I divide out a cosine x, I'm going to be left with just this. And if I divide that out, I'm going to be left with a 1. So now I'm going to use the zero product property. Oops. So let's isolate the trig function. So we end up with that. So I know cosine, 0 is going to be here and here. And again, I need to be real comfortable with my reference page, right, of here. Right, I know when is cosine 0, top and bottom. So this is pi over 2. And going all the way around is 3 pi over 2. For this one, I know my 2 triangles are here and here, because sine is positive there. Opposite, so that's going to be pi over 6. And if there's 6 sections, this last one's going to end up at 5 pi over 6. That's number 1. All right, number 2. Again, let's solve. We'll do this for all x. All right, let's take a look. So I want to try to, I have only one trig function here. That's good. Let's isolate it. So cross multiply, and multiply both sides by 4. End up with that. All right, now this is squared. So to get rid of a squared, I'm going to square root both sides. Square root of 4 is just 2, so plus or minus 2. Secant is 1 over cosine. So if I flip this, I have to flip this. So I'm going to flip that, and I'm going to flip that. All right, now I'm going to solve 2 problems. I'm going to do one for cosine of 3x equals 1/2, cosine of 3x equals negative 1/2, and let's get both answers there. So cosine is positive on this side. Cosine is 1/2 here. Again, 1/2, that makes the angle pi over 3. I'll do it down here. X equals pi over 3 plus 2 pi n. I'm going to go all the way around here to this side. X equals, that's going to be 3, 4, 5. So 5 pi over 3 plus 2 pi n. But it's not x, it's 3x. So I got to have that there. Now, to get rid of the 3, I've got to divide everything by 3. Divide everything by 3. That's the same as multiplying by 1/3. Right now, I can isolate my x. So this is going to be, make sure I'm on the screen. x equals pi over 9 plus 2 pi n over 3. X equals 5 pi over 9 plus 2 pi n over 3. Now, if you think about it, this is just going to be on the other side, right? Because it's negative. So I'm going to have the other options. I'll go ahead and write it out. 3x equals, this is 2 pi over 3. And 4 pi over 3. All right, divide everything by 3. Okay, and so these are my 4 answers. Some of you might have noticed that, hey, these are just opposite. This and this go together and are separated by pi. So if you wanted to, you can combine those, but I'm not going to worry about that right now. All right, number 3. Want the exact value. All right, so now remember, exact value for tangent. I'm going to slash out that side because it's an inverse function. Tangent is positive here. Root 3 is not a thing on one of these triangles, but root 3 over 2 is. So opposite over adjacent. That makes this pi over 3. So that's my answer, because there's only one triangle to be drawn here. All right. Next one. Now, be careful. I'm going to put a star on this. If it were negative root 3, it would be the bottom triangle. Just remember that if the triangle is on the bottom, I've got to go in this direction. So that's going to be negative pi over 3. I'm not allowed to go all the way around, right? Because this area is blocked off. All right, number 4. We want the exact value. Okay. So just like any other problem in math, we start with the inside. So let's figure out where that picture is. So cosine of 5 pi over 4, here's 1, 2, 3, 4, 5. So this triangle right here is root 2 over 2, root 2 over 2, and this is 1. So if I want the inverse sine of pi over 4, I've got to draw my triangle, or draw my circle. Sine is blocked off over here. Okay, now we have to be careful because all right, let's take a look at number 4. We want the exact value of the inverse sine of cosine of 5 pi over 4. All right, so I got to find out, just like in any other math class, I've got to work with the inside the parentheses first. So that's going to be 1, 2, 3, 4, 5. There's 5 pi over 4. So that makes the cosine of this is this right here, root 2 over 2. Since I'm going backwards, this is negative. So I have the inverse sine of negative root 2 over 2. That's what that is. So now I've got to do my little circle deal. But remember, the inverse sine gets blocked off over here. And just as a side note, sine and tangent are blocked off that way, cosine is blocked off that way for the inverse to exist. So now this is going to be down here. All right, now we just have to be careful. This is root 2 over 2. I think we're getting pretty good at knowing the root 2 over 2s are pi over 4. But remember, it's going down. Like I said over here, because it's going down, it's going to be negative pi over 4. All right. All right. Number 5. I want you to verify. Okay. So this is a question mark. Are they equivalent? Actually, they're telling me that they want me to prove it. So I'm not allowed to assume that they're equivalent. So what I typically do is hide one side. I'm going to work with this side. Looking at this, a 4, a 2, and a number. This is like a perfect little trinomial piece. And what it's going to hint to me is that this is going to be factorable. Now, you could kind of do a U substitution and call sine squared squared, and then this would just be a regular sine x, right? Sine squared is just going to be the U. So this will factor out to be this, right? Because these two multiply to that. My only option here is 1 and 1, and because that's negative, both of these are going to be negative. So let's verify that that works. Remember, I can check it. Negative sine squared x, negative sine squared x, that adds to negative 2 sine squared. So I'm going to erase it. So now this becomes that, right? Because it's the same thing written twice. So again, I'm still wondering, does this equal? This right here, whenever I see a sine squared, I should be thinking Pythagorean identity. So what I can do is take this, I'm going to do it in another color, and I have a little sidebar over here. Sine squared x equals 1. I'm going to solve for sine squared. All right. So then I can plug it back in. So then sine squared x equals 1 minus cosine squared x. Do you agree with that? All I did was move the cosine. So I'm going to do a substitution, replace sine squared with this. One minus 1 is 0. When I square something, it's going to become positive, and then that's going to get raised to the 4th power. So in fact, they are equivalent. All right, let's do another verify one. I want to verify that that's equal to sine. All right, what a mess. My go-to is get everything in terms of sine and cosine. Okay, where am I getting all this from? Bam. You should know this. This is something you should have memorized, especially for next year. You know, do you need to have all this now? You might need to double check these, but this you need to know, and this you need to know, and I would advise memorizing that first one. All right, let's do some cleanup. Too many fractions. So we're going to do a little bit of just a little bit of cleanup here. So I'm going to multiply everything by cosine and sine. Right? That's my common denominator. Maybe I'll do it in a different color. All right. So that's going to clean up. The cosines will cancel. Cosine will cancel with this one, so I'll get sine squared x. And then this gets distributed, so the sine will cancel with this one, and I'll get cosine squared x. Oh, this cleans up. Nice. So what is sine squared plus cosine squared? 1. That's that identity that I just said, hey, you might want to consider memorizing. Check. All right, number 7. All right, let's find this given. All right, so I don't know what that is, but what I can do is come over here and use one of the identities because all I'm given is sine. So let's see. Hey, look at this one. If I'm given sine and it's sitting there, I can just use this one. So I'm going to use this identity. So this one is going to be 1 minus 2 sine squared a. So now that's just going to get plugged in there. 1 minus 2. Sine of a is 3/5, so I just need to square that. So that's going to be 2 times 9 over 25. 1 minus 18 over 25. So that's going to come out to be 7 over 25, right? Common denominator. If you didn't choose that one, and let's say you didn't see that and you said, oh, I'm going to choose the first one, right? And you did this. That's fine too. It's just a little bit more work. What you would have to do is they gave you this one, so that's easy, but they didn't give you cosine. So that's where I was drawing the triangles. So if I do a 30, 60, 90 on this one, right? And if this is, let's say this is in the first quadrant, so it would get drawn here. The reason why they give you the quadrant is to tell you whether it's going to be positive or negative. So sine is opposite over hypotenuse. Pythagorean theorem says that must be 4. So cosine is 4/5 squared. So that's going to be 16 over 25 minus 9 over 25, which is 7 over 25. Same answer. So it really doesn't matter which identity you choose. Be comfortable using any of them. All right. Number 8. Let's go ahead and use the sum and difference identity to find the exact value of sine of 23 pi over 12. So what I'm asking you to use are these. Right, so I don't know how to find the exact value of that. So what I'm going to do is break this up into something I do know how to find. So I'm just going to kind of guess. I mean, one never works, right? So let's try 2 pi over 12 plus 21 pi over 12. These can be reduced to pi over 6. Hey, that's good. I know what that is. So this becomes divisible by 3, divisible by 3. Good. I know what the 4 is. So both of these are part of my special triangle angles, right? Pi over 6, pi over 3, pi over 4. So now I can do a breakup. This is the one they gave me. I broke it up by plus signs. So this is how I'm going to rewrite it. So sine of pi over 6, cosine of 7 pi over 4, cosine of pi over 6, sine of 7 pi over 4. So I've got to do a little bit of triangle drawing, right? Sine of pi over 6, bam, bam. So what's nice is I know that's 1/2 root 3 over 2. Okay. So now what I have is sine of pi over 6 is going to be 1/2. Cosine of pi over 6 is root 3 over 2. And let's get a plus sign in there. And now I'm going to do the second triangle. 7 pi over 4, 1, 2, 3, 4, 5, 6, 7. So it's going to be down here. So this is going to be pi over 4 is root 2 over 2 negative because it's going down, and cosine is going to be positive. So cosine is positive, sine is negative. So my final answer, root 2 over 4 plus negative root 6 over 4. And we can combine them. I can't add them together because you can't put roots together. All right. All right. And be sure and leave a comment or question at the end, and I'll take a look at those. All right. Have a good one. I'll see you on Monday.